Hi, guys. Today we're continuing with Chapter 9. So we just took a test on Friday on, is technically the second half of Chapter 9, which was how to solve a quadratic equation. That's an equation where there's an x squared and we have to do factoring or the quadratic formula. Starting today, we're going to learn how to graph quadratic functions. So we changed the word from equation to function so that we can graph it. And the one major difference between like the setup on these problems and the ones that we were just doing is instead of them being equal to 0, for this whole chapter, we're going to set everything equal to y. So we need to have two variables in an equation to be able to graph it on a coordinate plane. We need an x and a y. So we'll be replacing that number 0 with a letter y, and that will allow us to graph. And we're not technically going to be graphing today. Today I'm going to go over some vocabulary words, and we'll do a sample problem of like how to find those vocabulary words. And we'll start graphing tomorrow. And we're going to graph. That's kind of the big picture is like, can we graph this thing and can we analyze the graph? Can we find like the important parts of the graph? So let's get started. The shape that we will be graphing tomorrow is called a parabola. So the title, it says properties of parabolas. And parabolas, let me see if I can draw one for you. So a parabola is a U shape. It's nice and curved. So it's going to look like this. Now, up until this point in time, you've probably only graphed things that were straight lines. We graphed linear equations, right? And linear equations are in the format of y equals mx plus b. So because there's an x squared in our equation, that changes what the graph looks like. So the x squared is what makes it the U shape. Standard form, again, for this chapter is changing just a little bit. Instead of it's being equal to 0, now it's equal to y, so we can graph it. But it's still in that same progression, right? It goes x squared, x, just a number. So that's the same as what we were doing last chapter. In standard form, the letter A, that's the number that's right in front of the x squared, is going to tell us some stuff about our parabola, our U shape. So the first thing that the letter A tells us is it tells us which way the U shape opens. For our purposes, the U shape can either be a right side up U or an upside down U. Okay, so the one that I drew is right side up, and that will happen when A is positive. So if the number in front of your x squared is a positive number, then your parabola will open up like a smiley face. When your parabola opens up, it has a minimum point, a lowest point. That would be down here. In today's PowerPoint, anything that I'm writing with the red typing, those are all answers to questions that I will ask you. So when we're doing these parabola problems, I'm going to give you an equation and I'm going to ask you a list of questions. I think it's like 8 questions. So one of the questions will say, does it open up or, and then the other way would be down. And that would be when A is negative. And then another question I'm going to ask you is, does it have a min or a max? Okay, so when it's positive, it's opening up with a minimum. When A is negative, so when the number in front of the x squared is negative, then your parabola opens down, like sad face. And it has a maximum or a highest point, right? It's that top, it's the top of the U shape is the maximum. Up and min always go together, and then down and max always go together. The other thing that the letter A tells us is how wide the U shape is going to be. So we have a regularly sized U shape, but then sometimes it'll get wider, more flat, and sometimes it'll get skinnier or more tall. So the letter A also tells us that. Ignoring the sign, because the sign is telling us something different. If A is 1, it's going to be a normal sized parabola. And you don't know what that means yet, but we'll talk about that tomorrow. If A is greater than 1, even just like 1.1, the parabola will get skinnier. And if a is less than 1, so we're talking a fraction or decimal less than 1, again, we're ignoring the signs right now. So even a negative fraction or decimal, somewhere between 0 and 1, it's going to get wider. So it'll get more open, more bowl-shaped. When we're drawing a parabola, there is this line. It's an invisible line. So when we draw it as a dotted line. But there's this invisible line that goes through the middle of the parabola, cutting it in half. And that line is called the axis of symmetry because the parabola is symmetrical on both sides of the line. Since it is a line, we do need to write an equation for it. It's a vertical line, and vertical lines always have an equation of x equals. Now there's a formula for this, so we'll need to plug numbers into this formula to calculate the axis of symmetry. So x equals negative b over 2a. That should look familiar. It's everything except for the square root part of the quadratic formula. Remember, this is a continuation from our previous chapter. All right, so you'd plug in your b and your a, and you would simplify. And your final answer for the axis of symmetry, again, needs to be an equation x equals a number. So make sure that you're writing your answer in the correct format. On the axis of symmetry, where the axis of symmetry touches the parabola, that's called your vertex. That will either be your minimum, your lowest point, or your maximum, your highest point, depending on which way your parabola opens. Since the vertex is on the axis of symmetry, we can use the axis of symmetry to find the vertex. In fact, the x number for the vertex is exactly from the axis of symmetry. So whatever answer that you got here should also go here. Now for the y number, you'll need to calculate that. And basically what you do is you take your axis of symmetry and you plug it back into the original equation that you were given, and that'll give you your y coordinate. Those are great things to find because that's going to give us our starting point when we actually start graphing a parabola. And we will start graphing parabolas tomorrow. In the meantime, though, let's keep finding important points. So another important point on a parabola is the y-intercept. So the y-intercept is where it crosses the y-axis. And on a y-intercept, the first number is always 0. And then the second number is going to be your c. That's from your ax squared plus bx plus c. I know this is a lot of information, but we're going to keep practicing. Actually, starting in the next video, we're going to practice doing all of them. And this is basically all the information you need to know for this chapter. So we're going to just keep practicing until we get it down. Now, we're not actually going to be graphing today, but since I'm giving you all this information, we might as well write down how to graph. So when we're graphing, we start by drawing the axis of symmetry, which is a vertical dotted line, or you can use a highlighter, but you can't draw a solid line because it's not really there. It's an invisible line. Then on your axis of symmetry, you're going to graph your vertex, which is a point, and that is either the lowest point or the highest point, depending on which way the parabola opens. Next, we're going to use some special ordered pairs to complete the graph. The special ordered pairs are 1, 1a, 2, 4a, and 3, 9a, and we'll talk about those a little bit more tomorrow when we start actually graphing. The special ordered pairs are called special ordered pairs because they're directions on where to go from the vertex. They do not get graphed from the origin like most ordered pairs do. And again, we'll talk about that a little bit more tomorrow when we actually start graphing. Now, we already stated a y-intercept, but there are x-intercepts or intercept as well. So the final thing we're going to talk about in this video are finding the x-intercepts. To find the x-intercepts, the easiest way to do it is to just look at the graph and see, like, where does it cross the x-axis? Or, hey, everything that we did on our last test, technically, we were actually finding the x-intercepts of a parabola. We didn't know that at the time. So another option you have, and this could be a great way also to just check and make sure you've got the right x-intercepts, is you could solve by factoring. So you could replace the y with a 0, try to solve by factoring, or you could try to solve using the quadratic formula. Just like last chapter, normally we get 2 so two x-intercepts. But there's always the possibility that we will only get one. That's when we got a double root last chapter. Or there's also the possibility that we will get no x-intercepts. That was when we had the negative under the square root sign. X-intercepts need to be written in the format of a number, comma, 0, similar to the y-intercept where it was 0, comma, a number, but reversed because x and y are different. This concludes our first video. In our second video, I'll do an example of finding all of the things that we can find without graphing.